Hello and welcome everyone to this new video in our series about generative AI. In this video, I will be showing you how to use LLMs on Android systems. For that, we will be using the llama.cpp. So if you remember from the previous videos, this is the GitHub page for the llama.cpp. So on the master branch, you can see all the folders inside this repository. So if we looked at examples, now if we scroll a little bit down, you will see llama.android folder. And inside that, there is an application which is built using the Android Studio. So for now, I will open Android Studio. So this is Android Studio. It opens with the last application I was working on. So for now, we go to File, Open, and then we go to the programs llama.cpp. So this is where I cloned this repository from the llama.cpp. Then we navigate to examples and llama.android. We select this folder and we open it. It will open the application in a new window. Let's start now to simply run. So it took a few seconds. And then as you can see, we have the application here running in the emulator. I already have an emulator here set up and ready. Let me close this Bluetooth app. And this is the main interface of the application where we can download one of three modules. So let me zoom a little bit so you can see it. So here we have like three buttons to download the Phi, the Tiny Llama, or the Phi 2. So first you download, you choose what you want to download and click on download. The download is done. You can see now here we have load Phi, and if we click on that and scroll a little bit up, you will see that it's loaded. So now we can start chatting with this LLM. So let's ask, why is the sky blue? So after a few seconds, as you can see, we got our answer, and it's not a very good one, I will say. The question is asking for an explanation of why the sky is blue. That's not what I wanted. I wanted a real answer, basically. And I also wanted to use our LLM model, which we fine-tuned in the previous videos for the OA estimation. And for that, I will start a new application. However, before I do that, I wanted to explain a little bit the structure of this project, because I will be following the same structure in my new application. So let me minimize this and notice now that this project consists of two modules. So one module is called app, and this module is responsible for displaying the GUI and handling the different GUI events like clicking on the buttons. And there's a second module which is called llama. This module implement a wrapper around the llama.cpp. So you can see that we have here a CPP folder. Inside this CPP folder, we have the llama.cpp code, as you can see here, for example. And it also have this cmakeLists.txt, which is used to compile this code. So basically, to be able to run this application, you need to have cmake installed. And you also need a C++ compiler. For me, I have the Microsoft compiler because I already have Visual Studio installed. So let me minimize this, and let's look now inside this Kotlin and Java code. And inside that, we will have one file. It's written in Kotlin. It's called llama Android. This file wraps around the functions which are written in C++. So we can see here multiple functions which have the modifier external, and that means this function is not implemented in Java. And Android Studio shows you here the C++ icon telling you that this is implemented in C++. And it shows also that these are the GNI implementation for that. And GNI here stands for Java Native Interface, and that's the technology used to call C++ or code which are written in other languages from Java. So let's choose one function, for example, the load function. So if I press Control and then click on that, it will show me the GNI implementation. I click on one of them, then it will take us to the corresponding file, and this is a C++ file, as you can see here. And inside this function, the necessary code to load a GGUF file is wrapped. Let's go back to the llama Android Kotlin file. You can see that there are also multiple external functions, but then there are also some functions wrapped around those. So the external functions are all private, and then there are some Kotlin functions wrapped around those, and those functions are marked with the modifier suspend, which will cause us a small problem in Java, and we will see later how we will solve it. So here we have the load, which take as a parameter the path to the module, and it loads the corresponding GGUF file. You will see there is functions to send, and this is what we will use to send data to our LLM to ask it question. And then there's also the unload function. And these are the three functions which we will be using in our code. So in the second module, this application module, the llama module is used. So if we clicked on the project structure here, we can see that the app module does have the llama as a dependency here, as you can see. And this application has three files. The main file is this main activity, and there are two helpers files, and they are called downloadable and main view model. So the main view model implements the loading and communicating with the LLM. So you can see here imports this llama Android, and here it has a member variable from that class set to the instance. So this is a singleton from the llama Android. And let's see where this is used. So here in the on create and load it first. On the send, it sent the text or the question to the model. And then in the bench, also it called the bench function. In the load, it called the load function with the corresponding path. And that's it for this main view model. So in the main activity, we can see that this class extends the component activity. So it is an activity. In the onCreate function, we can see that it defines three downloadables. So one for each model, which we have seen in the GUI. Then it composes the GUI, so mainly in this function called main compose, which is a composable as you can see here. And in this function, we have the different text views, and then we have the different buttons. So the buttons for send, pinch, and clear. And then we have a button for each downloadable. So these are the three buttons which will enable us to download or load an already downloaded LLM. And that's it basically. And now let's start a new project with Java. And for that, we click on File, New Project, and I will choose Empty View Activities. Then Next, I will call this application Java Code Llama, and I will put it inside our repository in video 12. So the minimum SDK is 33. So let's keep it like this. And the build configuration language is Kotlin DSL. So that's okay. Let's click on Finish. This will create our application and open it in a new window. So here we have the app and the different build scripts. So let me now go to project structure and let's add a new module. This module is where we will copy the llama module. I don't want to rewrite that. So let's call it llama and use the same parameters from the llama module. So for the package name, I will use the same package name, which is android.llama.cpp. The language here was Kotlin, and let's click finish. So let's go to dependencies and let's click on app and click on this plus button to add a module dependency. And we have only one module, which is called llama. Let's click on that and click OK. Now what I will do, I will open this llama in the Explorer. So we go to open in, then Explorer. And here we have the folder on our hard disk. Let me now go to the llama.cpp examples, and then I will go to llama.android, and here we have the llama. Let me copy everything here, and I will delete everything here and paste. So let's look now inside the llama module, and let's reload from the disk. So now you can see we have the llama Android. Let's try to run. So we have an error because of the Gradle plugin. So I think that's because we created a Java application. Let me go to this project configuration. You can see here we have an application and a library plugin. I will add a Kotlin plugin, as you can see here. And let's sync now. So then we have an error in this cmakeLists.txt at line 35. Yeah, unfortunately the code is not loaded here. So I will open it from the Explorer. So go to the Explorer. I think it should be here inside the sources, main, CPP. And then here we have the CMake lists. So let's open it, for example, in VS Code. And in line 35, you can see it's trying to add a relative path. But since we are building now outside the llama.cpp, we need to put the correct path. And for now, I will not put a relative path. I will actually put the real path for the llama code. So that would be on our D drive, on the programs, and then the llama.cpp folder. Let me save and then try to rerun. So now we have versions problems. So we have a package which require the newest version of the SDK. So I want to use Kotlin also here because we have to wrap around the llama Android class since it has the suspend functions. So I will go to the application configuration and I will add also the Kotlin plugin here. And let me sync now. And let's try to rerun. And for compiling our application, let's use SDK35. And let's see if that will solve the problem. So now the application runs. And as you can see here now, the folder called Kotlin plus Java, because we added this Kotlin plugin here. And I want to add one Kotlin file. So let's go inside this Java code llama and have a new Kotlin class. And let's call it LLM wrapper. And I already have the code for this class. Let me paste it. So as I said, this class will wrap around this llama android. So we'll have this llama android member variable, which is from the class llama android, and it's set to the instance. And we have this interface called message handler, which have only one function called handle, which will take a string. And then you can see here we have the load, which will use the global scope dot launch, and then we have this load. Similarly, for the unload, we will have global scope.launch, and then we have the unload, and similarly for the send. This I have to do because of the suspend functions, which we have seen in the llama wrapper. So this function here, because those functions cannot be called simply with one string parameter, and that's why I wrap them around like this. And now we really can use this LLMW in our Java code, and we call it like simply by passing string arguments. And actually here for the unload, we don't need any argument. And now let's go to the activity layout, and I will replace this hello world text view with a scroll view, which has a text view inside it and an edit view. So you can see here now we have this text view, which sits inside linear layout, which is again inside the scroll view. And then here we have this edit text. So let's save this. And since I want to use those, I need to be able to refer to them. So for that, we can use defined by ID, but I actually prefer to use the bindings. And for that, we need to go to the application. Then here inside the Android, we have the build type, compile options. Then here we add build feature, and we put view binding to true, and then we sync. And now inside the main activity, we can use now a new class which is generated for us, and it's called activity main binding. And I will define a variable from that called binding, and this will be activity main binding dot inflate. And for the inflator, we will get the layout inflator, and that's it. So we have now our binding, so we can set content based on that, and we don't need these two lines here, and we don't need these lines here. So let me delete them, and let's define a variable from the type LLMV. And then here in the onCreate, I will add a try catch block. So if any exception happened here, I will show it in a toast. So the first thing I want to do inside this try catch block is to load our module. So for that, I need to call load, but this load needs a string path. And for that, we need the path of our GGUF. So let me go back to the Windows Explorer. And now let's go inside the application to the resources. And here I will add a raw folder. And inside it, I will put our fine-tune GGUF. So that was inside this models folder, and I will copy this DOA. So as you can see, it's like very big, 1.2 gigabytes, almost 1.3. And let me put it here inside the row. And since we'll be a resource, we need to follow the naming convention of the resources. So I will just use small letters for now, call it DOA. So remember, this is not recommended because this will make the application size goes very high. So it will be more than 1.3 gigabytes, and that's really not recommended. So it's better to have this GGUF copied to your mobile device on an external path and then load it from there. But for now, I will do it anyway like this. So I put it inside now the row. So now if we came here to the resources, we can see that we have raw resources and this DOA GGUF inside it. And since here we need a string, cannot use the normal way of loading resources here. So what I did is that I created a function called prepare path. I will paste it here. So this function, as you can see, it uses get resources, and then it gets the resource using the ID as before, and that will give us an input stream. And then it will create a temporary file and copy this file to it. So now we are really copying the model outside the package, which is not good. So if you have it already outside and you have the path, you don't need this function at all. Yeah. But anyway, now I did it like this, and this function would return the path of the temporary file, which is a string, and this we can use. So here I will just use prepare path, and that's it. This should load the LLM. Let's try to run. So you can see now the first error because of this big size is that we are out of memory. So let me go here and put this to a bigger memory size, sync, and then rerun. So we have an error here, and it looks like we have different versions used for the Java and for Kotlin compile. So let's check the settings of the app. So you can see here we have the Java version 1.8, and where do we have the Kotlin? So we don't have any Kotlin options. So let's Kotlin options here, and let's put it to 1.8 also. Do we have the same here for the llama? Yeah, for the llama we already have it here. So let's sync and rerun, and you can see now the application built, but it will not run on the emulator since it's a huge size, as I said. So let me close this emulator. Now I'm connecting my device, a real Android phone. It's a Samsung phone, and let's try to run on that. So we need to have an SDK of 29. So let's change it. Let me do the same for the llama. So I already did it for the llama. Here I need to do it for the application. Let's save and sync. Let's now rerun. Now we can see the device, so the application is already loaded. So here we have our edit box. Let me now go to the code. So I will close some of these files and go to the layout first. And in the layout, I want to change the text. So I don't want it to be name. I want it to be a question for our GGUF, which we already trained for DO estimation. So I will ask it, what's the separate algorithm for direction of arrival estimation? So to save myself the typing time, and let me save this. And now let's go to the main activity. Now we have the LLM loaded. We need to add an event handler to our text box. So when we click enter, and for that I will use the binding, and then we have our edit text box, and then I will set on editor action listener, and then for that I will create a new action listener. And as you can see in this action listener, we need to override this function on editor action. And for that, I will keep this return false in the default case. But if the action ID, which is here set as I, but I will put it action ID anyway. And let me replace this I with action ID. So if this is equal 0, this is what I will get when I click enter. Then we will get our question, which is from the binding again dot, it's called text view. I did not change the default name. Then get text. Then remember that this text view here will be referring to the edit box, since it is the component which we are calling this set on editor action listener on. So if I wrote text view dot set text and I put it to nothing, then that will clear the text inside the edit box, and then I will send this question to the LLMW. For that I will use the function send, and as you can see now, this function send will take a message, and that would be our question. And then we need this message handler, which is an interface we created in this Kotlin wrapper. And for that, I will create a new message handler. And we need now to implement this function ach, which stands for handle. And for that, I will call the main activity.this.run on UI thread, because we need to update the GUI. And for that, we need now a new runnable. And you can see now for the new runnable, we need to implement this function run. And in the function run, let me collect all the strings. So I will define a string called all, and this string, I will have it from the binding.text view. So everything on the text view, get text. Then I will add to it the message which we got as an input to our function ach. So sg, and then we'll set the text of the text box. So binding.textbox.set text, and we will put it to this all text. So that's it. Let's save now and rerun the application. Let me make this a little bit bigger so you can see what's going on. So as you can see now, here we have what's the split algorithm for direction of arrival estimation. So if I clicked here, it did not respond because I need to click the enter from my computer. So let's fix this. So we will add or action ID is editor info, I think. Then let's put done or action ID equal to, let's say next. What's also there, I think go. and send. And there is a bug here. So this text view from the binding does not refer to this edit box, but rather it refers to the text view here inside the scroll container. So to fix this, I need to take edit text. So this refers really to this text here from the question. And now let's run. So now the application is running. Now let me click here inside the edit box and then click OK. And that should trigger our LLM. So you can see it started now answering, and I would say it's pretty fast. Don't forget that this is running on a Android phone, and this is not the newest one, I would say. It's like 4 years old. And you can see we got our answer. So the Esprit algorithm is search-free subspace-based algorithm for DOA estimation. It uses eigen decomposition to estimate the signal subspace, then the DOAs, which is perfect. So as you can see, we have now a simple way to run LLMs on our Android devices. This method goes through the llama.cpp and is based on these GGUF models. However, don't forget that including such big models in your resources is not a good idea. I did it here because it's faster to program like this. So please put your model in an external directory, and your compile and load time of the application will be much faster. That's all for this video. I hope you liked it, and see you in the next video. Bye.